Good evening. Today I will be going over free radicals and briefly over stability. Free radicals are very, very reactive. This is something that you will learn in Organic Chemistry 1 and is partially fundamental and something you should understand relatively quickly. So, what are free radicals? Well, before we actually get into the chemistry, I'll briefly go over it so you have a more fundamental concept of free radicals. Well, I'm sure you've heard of the term free radical in the body. Well, usually that's an oxygen that is unpaired and goes throughout the body and destroys cells and DNA and so forth and so on. That's more biology based. And how do you get rid of that? Well, you get rid of that by taking antioxidants, which give that oxygen the electron it needs so it does not take them from other things within your body. So let us get started here. So let's talk about stability here. Stability with free radicals is pretty quick. I'm going to go over that very quickly. So we have benzylic. That is the most stable, which pretty much is a benzene ring. You know, the most stable. Following that we have tertiary, which would be something similar to this. Then secondary, which would be like having carbon to the left and to the right. And then primary, which is usually on the edge. So like a carbon up here, it'd be, you know, it'd have our hydrogens. It'd be something that's right here. Secondary would be like right there. And tertiary would be right there. And then with the methyl is the least. So it goes benzylic, tertiary, secondary, primary, and then methyl. And that's usually how it goes. It's the same with carbocations when it comes to an SN1 reaction. It goes for the most stable. And in organic chemistry, stability is key. So let us talk about free radicals now. So free radicals happen in 3 steps. 3. First step is initiation, followed by propagation, and then termination finishes everything as it says in the name itself. Some fundamentals before we actually start this small reaction. So we have 1 electron. Usually you're used to using 2, an arrow, but 1 electron is represented with a hook. That shows that 1 electron is moving, which will be used frequently in free radicals because, after all, free radicals are mainly dealing with just that 1 electron. 2 electrons would be an arrow. See? Not a hook, here's an arrow. That's the second fundamental. Third is, what does a free radical look like? We'll use chlorine, the halide, pretty simple. Just draw pairs of electrons. And this chlorine wishes to fulfill the octet rule, but the free radical gives it that 1 odd unpaired electron. And when that happens, this becomes ultra reactive and will go for anything that it can, any electron it can get. This reaction will show how that works. So here we have ethane plus Cl2 is going to yield to 1-chloroethane plus HCl. And that's what we're going to make. We're going to make this product right here. And we're going to start off with this. So, the initiation. How do we start this? So we have some Cl2. Well, in order to break it up, in order to break this Cl bond, so here we are. Regular Cl bond. We got to break that sigma bond right there. So, what do we use? Well, you could use UV light or heat. And UV light is used quite frequently to this. So we have our UV light right here. What it's going to do, it's going to break this bond. So we're going to have the hooks because 1 electron is breaking apart. So once that happens, here's the blue here. Now we're going to have that unpaired electron right here and right there. Fill these in. So now that we have that happening, we are going to go to the next step. But before we go to the next step, let's look here. See this now? This creates 2 chlorine free radicals. The free radical on a chlorine is, or any halide or whatever it may be, is notified by one electron. All you have to do is put 1 electron, and then you'll know that that is a free radical. So here's the first step. We break the bond. So second step, go in color order here. Second step is propagation. So propagation is pretty much one step, but it has 2 parts to it. So let's start off here. So we will draw the ethane. So remember CH3 bond to a carbon with our hydrogens. And this is where the reaction is going to take place. This is why I'm drawing it out. And then we have our chlorine free radical waiting right here. So what's going to happen? What's going to happen is he's going to look. Alright, well it looks pretty stable here. Well, it's pretty much the same thing. So first this bond's going to break. So this hydrogen is going to break. Remember, 1 arrow. And this guy's going to come on in, it's chlorine. And this is going to yield to CH3 carbon to our hydrogens. And then it's going to also do the HCl. Tetrachloride. But what's happening here is, now that that electron, this free radical is over here, now we have a free radical. So now it's CH3CH2 with free radical plus the HCl. So right before we get the terminations, another step has to happen. We have to turn this into 1-chloroethane. So how are we going to do that? Well, we're going to do a little cut here. 2B. This would be like 2A. That's 2B. So 2A. So now we have our free radical. So we're CH3 with our CH with our free radical. And now what happens, now we're going to have that Cl and Cl2 come in. And what's going to happen? That bond's going to break now. Because he wants a chlorine. So the chlorine's going to break. Hook. And that's going to yield to. Now he's going to come over here. So now 1 pair of electron. Now we have that 1 electron here, because now this is a free radical as well. This is, now there's 2 Cl free radicals. 2 of them. So now one of them is going to come over here. And now it's going to create a bond. So now our new bond is going to be, now we're going to have the CH3, the carbon, the hydrogen. Now it's attached to a chlorine. And what happened was, as I said before, the free radicals, I'll do it in blue, merged. They create a sigma bond, as we see right here, which is half of our product. But we also made the HCl already. But in this step, we have that other chlorine free radical. And what happens, this happens within millions and millions of molecules. This whole process is happening in a vat, or whatever it might be, a vat, or whatever the reaction is occurring in, or a beaker. So now we're going to get to step 3. I'll erase. This is what it looks like. Now we'll do step 3. Actually, I might be able to fit it in underneath here. So step 3, termination, the final step, which is pretty much this whole thing finishing up. So we're going to have 2 free radicals come together. And this is finally everything summing up. So now we have our CH3, their hydrogen. But this time, this one's going to have a free radical. So here's another one. And then we also have our chlorine, which has his own free radical. We'll just have it there so it's closer. Now they're going to want to intertwine here. So they're going to want to create a bond. And that's going to yield to the creation of our product, which is CH3, C. Now, actually I'll color code the bond so you know what it looks like here. So we have our green arrow. Green arrows come together. Ta-da! We have that. And then we have our chlorine. In this case it's black. So now we have one chloroethane. And that is our product right here. And that's just a simple reaction step by step of what happens with free radicals. Now more complex ones can happen, but that would involve different stabilities. This is just a fundamental. You can try this with cyclic structures or alkyl structures, but that is the basis of free radicals. Thank you.